Yes, start Aditya.
Magnetic effect of electric current. Activity 14.5. Take the cardboard, try from inside a discarded matchbox. Wrap an electric wire a few times around the cardboard tray. Place a small compass needle inside it. Now connect the free ends of this wire to an electric cell through a switch as shown in figure 14.17. Note the direction in which the compass needle is pointing. Bring a bar magnet near the compass needle. Observe what happens. Now, while watching the compass needle carefully, move the switch to the on position.
Yes, next.
What do you observe? Does the compass needle deflect? Move the switch back to the off position. Does the compass needle come back to its initial position? Repeat the experiment a few times. What does this experiment indicate? We know that the needle of a compass is a tiny magnet which points in north-south direction. When we bring a magnet close to it, the needle gets deflected. We have also seen that compass needle gets deflected when the current flows in a nearby wire. Can you connect the two observations? When the current flows through a wire, does the wire behave like a magnet? This is what a scientist called Hans Christian Ørsted also wondered. He was the first person who noticed the deflection of compass needle every time the current was passed through the wire.
Okay, now stop.
So,
So just wait. What is it? So we have made a circuit. Okay. So for the circuit we need a battery. Okay. We have a battery. We may attach a appliance. Suppose we have attached a bulb over here. Okay. And in the other end we have taken a matchbox. Matchbox. All of you have seen. मम्मी दिया जलाने के लिए use करते हैं. Have you
Yes,
seen
ma'am.
matchbox?
Yes, ma'am.
Inside the wooden matchbox we have kept a compass. And you know the magnetic compass is having a needle between and they show the north south direction that you
Yes,
know.
ma'am.
So all of
Yes,
us
ma'am.
know
Yes, ma'am.
that shows north south direction. So what will happen? And if we just we are taking the wire and we just making a coil around this matchbox that is having the compass, and then again connecting and making the circuit close. We may attach a bulb or not, nothing. It has been not told that we are attaching a bulb over here. So what we are making the circuit which is having the wires are there, the components, the battery or the cell is there, and we have taken a matchbox inside which we have placed a compass, magnetic compass, and we have coiled the wire around the magnetic compass. Am I clear?
Yes,
Yes,
ma'am.
ma'am.
Yes.
So we will take this kind of wire are all that it is available at home. Yeah, if you are having that magnetic compass and a matchbox, we are going to coil, ऐसे करके coil. We are just going to coil round. I have told you that how you are finding the north-south direction in the important points. Yes, we have done.
yes, ma'am.
So like that, what will happen if you
Yes,
just
ma'am.
make the switch? We can just have a on and off switch over here. So in this position, what will happen? The switch is on or off? It is in the
Ma'am, the
off
Off.
switch was
position.
I'm
in
off
That
on.
is the
position.
Ma'am,
circuit
off position.
Ma'am,
circuit is open. So now the circuit is
Yes,
open.
ma'am.
Let me point it. Just wait. I think now you are able to see. So it is in the on off position. So if I
Yes,
make
ma'am.
it touch with this two terminal, it will be in the on
I'm on
position.
position.
On.
Ma'am, on position.
I'm
So
on
what will
position.
happen? Electricity will start to flow from the positive terminal to the negative terminal. As a result,
Yes,
what
ma'am.
is what you are going to see if there is no bulb over here, how you are able to see that electricity is flowing through it? You will see that this magnetic compass will deflect. That is, the compass that is having north
Yes,
south
ma'am.
direction will deflect because why? Because the coil that I have wrapped around this matchbox, I told you, when we see the clockwise direction of the motion of the current, that end will be the north pole. Yes or no?
Yes,
And
ma'am.
the
Yes, ma'am.
and the anti clockwise is north pole. Yes, and the anti-clockwise direction will be, ठीक से
North
बोलो,
Pole.
ma'am, South Pole.
साउथ में हम सही बताएं.
नो मैम। मैम जो एंटी क्लॉक है मैम वो नॉर्थ,
Ma'am,
और मैम जो क्लॉकवाइज है मैम वो साउथ।
Yes. So the clockwise direction will be the south pole, and the end from which we see that the electricity is flowing in the anti-clockwise direction, it will be the north pole. So what will happen if the north pole of the compass is over here? So it will get attracted towards the south pole. So the compass will move towards this south pole. So the compass needle will deflect. Deflect मतलब थोड़ा सा shift हो जाएगा. Shift in position is called the deflection. Okay. So now there will be deflection, and this shows what? That this coil has acquired a temporary magnetism. As a result, this magnetic needle is getting deflected. It is getting influenced by the electromagnet that we have produced by the coiling. Is it clear to everyone? This is the experiment
यस मैम।
and has been done by the scientist. Underline the name of the scientist, very important. It's Hans Christian Oersted. Based on his name, we are going to give some units, name of some units also. You are going to learn it in class 10. Okay, now continue, Aditya.
so, when electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of the electric current. In fact, an electric current can be used to make magnets. Do you find it too surprising? Let us try it now.
Okay,
Ma'am, the
now
blue
again
box
this activity you are able to do. Am I clear? 14.9, all of you are having screw, this kind of screw.
यस मैम।
घर में सबके पास है, मम पापा के पापा को पूछोगे, you will get that he be
Ma'am, it is
having
not
this.
14.9, it is 14.19.
Sorry, 19, sorry. Yes, so that screw up that you're having, all of you are having. And the other thing is the wire and the circuit you have to make. You have to make a switch, or a switch is always available in the market, I told you. And you have to attach it with a cell or a battery. Okay, so what will happen? What do you see? What do you experience? Anyone can express, tell me that what do you experience? Yes, Utkarsh.
मैम वी विल एक्सपीरियंस दैट द ma'am, the iron which we have taken will be act like as a electromagnet, as it will attract the nails, iron
Very
nails
good.
which we have
Yes,
put.
so this iron, this I'm just replacing over here. I'm just replacing the circuit that has been shown over here by the iron nail. Okay, so we have take the iron nail, and you have seen iron tail is like that. So we have coiled around the wire around the iron tail. So what will happen? We will see that the iron nail has acquired some temporary magnetism. How we will prove that it has acquired temporary magnetism, that is electromagnetism? How? If we bring some iron pieces over here, it will get attracted. If you bring a safety pin or a bolt pin near to this iron nail, what you will see? The iron nail is attracting all those magnetic material. Hence it is proved that when electricity is passed through some magnetic material, that material starts to become an electromagnet, and it is the magnetic effect of electric current. Clear? If any
Yes,
doubt you can ask, please. Any doubt, children? Any doubt?
Ma'am, no doubt.
Okay,
Ma'am, understood.
okay, just Aditya read the rest that small note.
Remember not to switch on the current for more than a few seconds at a time. The electromagnet weakens the cell quickly if left connected.
Okay, yes, that is the thing we have read in class 6 also, that remember we should not switch
yes,
on the current for more than a few seconds, but just for a few seconds, because it will exhaust or it will use up all the chemicals that are present inside the cell or the battery, and the cell will be exhausted quickly. We will not able to do any other further experiment. It becomes heated also. That is the heating
yes,
effect.
ma'am.
Whenever electricity is produced, I told you that it produces heating effect. That is heated. But along with that, all the chemicals that are present, the dry chemicals that are present inside the battery or the cell will be exhausted. Khatam ho jayega na. They will start to do chemical reaction if the circuit is always in the closed condition. That is why we always need a switch to operate it. So whenever
Yes,
our work is off, the switch should be in the off position so that the circuit will be open. Otherwise, all the chemicals that are present inside the cell will be drained off. Clear?
Yes,
Yes,
ma'am.
ma'am.
yes, ma'am.
Yes, Hassan. Now Hassan is going to read activity 14.6, where you are going to see that how the electromagnets are being prepared. Okay. Yes, Hassan.
Okay, ma'am. Activity 14.4 electromagnet. Activity 14.6. Take around 75 centimeter long piece of insulated plastic or cloth covered or in a, ma'am, what is written here?
Plus
Ma'am,
in enameled
okay, ma'am.
मतलब
Enamel.
क्या है? What is it? What we are doing actually? What does this mean, Shraddha? What you are doing actually? What you are taking? We are taking insulated wear. Okay.
Okay, ma'am.
The
Yes, ma'am.
insulation may be by plastic. Plastic is also a poor conductor. It may be with cotton cloth, that is the strings cloth. The cloth is also a bad conductor. And also it may be enamel. Enamel is also a type of chemical which is not a good conductor
Yes,
of electricity. So all these three, either of these three coating should be there on the surface of the wire so that it becomes insulated. Clear, children?
Okay,
Okay,
ma'am.
next.
Plastic or cloth covered or enameled flexible wire and an iron nail, say about 6 to 10 centimeter long. Why wind the wire tightly around the nail in the form
Wind.
of the coil.
यहाँ पे wind नहीं, we should not pronounce as wind. We will pronounce it as wind. Wind means we're just coiling around. Okay, wind.
Okay, ma'am.
Wind मतलब उसको बांधना, winding up. Wind up your things मतलब जो आप फैला के रखें उसको फिर लपेटो. But that is winding. तो यहाँ पे हम लोग
Okay, ma'am.
pronounce करेंगे wind, not wind. Okay, now carry on.
Connect the free ends of the wire to the terminals of a cell through a switch as shown in figure 14.19. Place some pins on or near the end of the nail. Now switch on the current. What happens? Do the pins cling to the tip of the nail? Switch off the current. Are the pins still clinging to the end of the nail? The coil in the above activity behaves like a magnet when electric current flows through it. When the electric current is switched off, the coil generally loses its magnetism. Such coils are called electromagnets. The electromagnets can be made very strong and can lift very heavy loads. Do you remember the crane about which you read in chapter 13 of class 6? The end of such a crane has a strong electromagnet attached to it. The electromagnets are also used to separate magnetic material from the junk. Doctors use tiny electromagnets to take out small pieces of magnetic material that have accidentally fallen in the eye. Many
Okay.
toys also have the electromagnet inside them.
Okay.
14.5.
Just wait. So what has been that we have just make the circuit closed. So we have make the circuit closed. So what will happen? Electricity will flow through the circuit and through the coil around the iron nail. So now if you bring some pin or anything that is a magnetic material to it, it will show attraction. This iron nail will attract those pins. Okay, and
Yes, ma'am.
at the moment you will switch off, what will happen? You will see that they are dropping down, the pins are dropping down. At the moment you are putting it in the closed circuit, then you will see they will show attraction. At the moment you are making the circuit open, then it will lose its property of attraction. So it is a type
Okay,
of
ma'am.
temporary magnetism, है ना?
Yes, ma'am.
yes,
So yes, this is a type of temporary magnetism based on which we have read about the electric bell also. So at the moment we are putting the circuit on, for the very moment what happens, the electromagnet attracts the metal and the gong strikes on the and the sorry ball strikes on the gong. And what happened, when at the moment it is striking on the gong, what is happening, that electric circuit is becoming open and again it stops. So like that repeatedly you are just pressing the bell, it starts to work and at the same time it becomes an open circuit. So these are the properties or the utility of electromagnet. Is it clear?